All right, friends and neighbors, time now for another networking video. I thought we'd start in on a Juniper series. So we'll start off talking about the chassis, and then we'll get into some basic configs, kind of the same stuff that we've done previously with all the Cisco gear. And speaking of Cisco gear, almost all of the configs and the packet captures and things like that that I've done on this channel have been run on a variation of small Cisco gear, and some of it's actually been quite old. But it does the job, so most of the stuff that we've been working with are 3550 and 3560 series switches, and then 2600 and 2800 series routers, and that's images of what we've been working with. So pretty straightforward, not high-end gear, but it does, like I said, it does the job. And just for fun, to get a little better idea of what they can do, here are some numbers. So on the back planes of these, and the forwarding capacity, 32 gig. Now all of this stuff, of course, varies a little bit with modules and models and things like that. I notice one of the measurements here is a PPS measurement. So our bullet number 2, 6.5 to 38.7 mega PPS. That's packets per second, which is an important forwarding number. On the switch anyway, the capacity in terms of memory for MAC addresses, 12,000. Unicast routes, we have the ability to keep track of about 11,000 routes. The 2811 router can do quite a few more than that. And then we've also got 1,000 multicast routes or IGMP groups that we can keep track of. And then the max MTU, if you happen to be working with jumbo frames, is about 9,000 for a maximum Ethernet frame size overall of 9,018. As we move into Junipers, this is an example of a Juniper EX4200. So we've got two flavors of Juniper switch we'll be working with, 4200s and 3200s. And they're just variations on a theme. They're stackable, meaning that you can put a bunch together and create something called a virtual switch. These are a little bit better machined than the 3560s or 3500 series switch from Cisco. They have a backplane of 128 gig and a data rate of 88 gig through the box, and then that's the 65 mega packets per second again, which is nearly double what most of the boxes can do in the Cisco. Lots more MAC addresses. Jumbo frame, a little different size, so sometimes that's an interoperability problem. More multicast routes and more IP version 4 routes as well. Lots and lots of VLANs. That 4K number for VLANs, that's typical. And then ARP table entries of about 16K. So we can almost say that the Juniper chassis, at least this one that we're working with, about doubles the capacity of the Cisco. A couple of more details. The virtual chassis or virtual switching means that you can stack up to 10 of these together, and then they'll appear as if you're talking to one box, which is kind of handy. This series switch is actually a pretty heavy-duty switch and can be used for data centers and things like that. Like the 3560, they can do some layer 2 switching and routing. The 3550 also does that. Where we usually talk about Cisco iOS, we're now going to be talking about Junos or Junos OS. And one other detail, at least for my quality of service students, is that we've got 8 quality of service queues per port, and all that means is that we have the ability to keep track of different flows, different priorities, different classes, and apply different settings or different characteristics to each one of those queues. So from the documentation, this is what the front of the ESX 4200 looks like, and there's the back of it. And while I don't expect you to get too much out of this, there are a couple of things that I wanted to point out. One are the management port and the console port, and I'm going to use this video to talk just a little bit more about those. Those are important features to us, especially as we start to think about more advanced concepts in network design or network management. So let's take a look at the front of the chassis. Two details that I wanted to point out here is that if you're on a Cisco, particularly a Cisco switch, there's a mode button. And so a lot of times we get used to looking at, oh, let me see what the link lights are doing. Oh, look, my link lights are green or my link lights are blinking, and that's all I need to know. But it turns out that there's a mode button on the front of many switches that will actually change the meaning of what those link lights do. Are they in full duplex? What is the backplane capacity of the switch, or what portion of the capacity is currently being used? So the lights will light up in a certain number or a certain amount of lights over the total, giving an indication of how much capacity you're actually using. And the Juniper is no different. The Juniper also has an LCD readout in the front that can tell you what version of the OS is running on the machine. It can tell you about the alarms, and can tell you about, or you can actually do recovery from that LCD. So don't be afraid to look at your boxes to see just what the heck those front switches or buttons can actually do. Now, the router that we're going to be playing with is a Juniper J2350, and what I'm indicating on the front here is where the power button is, and the power button is also how you're going to do recovery. But there's also a reset button there, and the reset button allows you to get to a recovery configuration or reset the configuration if you do something like put in a bad config or want to recover a password or things like that. So a couple of features on the boxes themselves. So let's actually talk about the management versus console. We're used to seeing that on a Cisco. It's exactly the same on a Juniper. You plug in a serial port or a USB to serial adapter, DB9, and you've got your standard console entry. Now I'm going to make a point here that console connections are not Ethernet connections. A lot of times students will make the mistake of trying to connect those two together. They are not. One is a serial connection based on EIA 232. Usually has a top end of 115.2 kilobits per second, and it's used to manage the box. It is also what we call out-of-band management because it doesn't use the same resources as the network traffic that you would see for nodes or for other management techniques. So other kinds of management are typically called in-band management. In-band management, meaning that it uses the same bandwidth or the same pathway that production network traffic uses, would be things like SNMP, Cisco Discovery Protocol, Telnet, SSH, HTTP, HTTPS. All of those things are all in-band management. Okay, so you have a couple ways that you can manage a box, and that's in-band and out-of-band management. What we're introducing here is a separate management port. And the nice thing about a management port is it's another network connection, but it's not a network connection that you use for production network traffic. So the weird thing about it is it's a management Ethernet connection that's IP network that is out of band. All right, so it is going to use a separate network connection entirely. And I'll give you a topology diagram that shows you how that works here in a little bit. It's the exact same way that you would Telnet or SSH or anything else to a box, but again, we're going to use a separate connection. Now here is a basic configuration for a management interface on a Juniper. By the way, any vendor that has a management port would also be configured in the exact same way. And this is also how you would configure a regular interface as well, but we're talking about management here, so I thought I'd point this out. This is their recommended configuration, and so the indication here is that depending on what Juniper chassis you're on, the management interface is called something different. So you figure out which one you have, which kind, give it an IP address, and then commit it. And then they've also got a notation here that their recommendation is that you actually use groups to manage that, and we'll talk about those at some point in the future. But essentially what you're doing is you have a separate physical connection to the box that's network-based that you can use to manage this box. And just for fun, I have an EX3200 that I'm also playing around with, and I just pulled up the management interface for that. So that's the bottom right that you see here. Okay, so this is traditional management. So if we're on Cisco, the management interfaces that we're used to dealing with are things like loopbacks and bridge virtual interfaces and the management VLAN, VLAN 1 in the case of switches. And the whole point is to give it non-physical virtual interfaces, not tied to a physical interface, and to give them IP addresses that are not on the production network. So on the bottom part of this, you've got your PCs and your notebooks and printers and everything else that are tied to the production network. And then connected to the same devices over the same pathways, you've got your management box, but that management box is talking to all these virtual interfaces. So it's in band, same physical pathways, same resources as production traffic, but different, but different logical interfaces. So it is different than the regular network connections. And here is out of band management using the management ports. So all of your devices now are going to have these management ports that are connected to a separate network. So they're still Ethernet, they're still IP addressable, but they are actually physically connected to a different port and use different resources and go to a different management network. And that's how you access it via Telnet or SSH or using SNMP or something of that sort to gather telemetry. So that's the fundamental difference. It's a different way to think about managing network devices. It's shall we say, a more production, more enterprise scale sort of thing. Well, I think that'll do it for this particular video. Next up, we're going to do some Juniper basic configs, but I thought it'd be good to get used to the chassis and talk a little bit about some of the differences between the boxes and where we're going. All right. Thanks for watching. Thanks for listening. And may your packets always reach their destinations.